So let's see. What we are trying to study is image formation. Image formation by a lens. And when we talk about image formation by a lens, we study convex lens in majority. All the diagrams that are given in your book are also for convex lens. Okay, convex lens is studied, convex lens in majority. This is, see, if anybody of you thinks that next year you would be getting into CBSE or you're getting into state board, all this, you should have a little bit of knowledge, because there they will study this and you have no previous idea about it. When we talk about image formation by a, say, a mirror, when we talk about image formation, mirror, though you did not study at all. Mirror, done, the majority that we study are concave mirrors. Convex we don't study. Okay, in lens we will always study convex. A convex lens is a lens which is like this. In crude language, the hand lens or the magnifying glass or the hand lens, we call it as the hand lens. And in biolab we call it as the simple microscope. Simple microscope. These are all examples of convex lens, right? These convex lenses will always give you image which are, again I'm saying, which will be inverted, which will be real. And now I'm writing something in yellow, except one case. Now you should have immediately actually argued with me. How do you say, sir, real? Because when I use my magnifying glass, I never see something inverted. I see it straight. That's why I said except one case. And except one case means in this case you will be finding a virtual image and you will find an erect image. You will have all three combinations, and this will be magnified, or rather I should use the word enlarged. Okay, enlarged. Here we will get real, we will get same size, various combinations we can guess. We can get enlarged, and we can also get smaller than object. Smaller than object. Clear? Except one case, and put this in red. This is a single deadly combination that will happen. No other case it will happen. And this case is the case when you use it as a magnifying glass, when you use it as a hand lens, when you use it as a simple microscope. Otherwise, all we will get always is inverted. The lens in your eye is also convex lens. So if I am watching Dhruv, the actual image of Dhruv in my eye is inverted Dhruv. The brain is again correcting it to straight. The first image of Dhruv that is on my eye is inverted only, right? So let us see the various cases. Are we ready? Okay. So I'll draw one diagram first, and then you'll get a bit of idea. I'll show you how the diagram is drawn in your book. So we'll see that deadly combination. Okay, first we'll see that deadly combination. In your book, they have shown a vertical line, but if you go and see any other book of physics, you won't see a vertical line. All you will see is a lens. So in your book, in none of the diagram, the lens part is covered. So there's a lens like this. This is my convex lens, right? What is this line? This line is known as the principal axis. This is an imaginary line, and it is perpendicular to the axis of the lens, passes through the center of the lens marked as O, and O is known as my optical center. Whether it is in your book or not, please make a note of it. Otherwise, there's no point in learning optical center. Okay. Now there are some conventions also that we use. What is the convention? The convention that we use, though you don't have any numericals to solve, but the convention is something like this. It's like a Cartesian coordinate system where the lens is always, it's a Cartesian coordinate system and the lens is always placed with the pole at the origin. The lens is placed in such a way that the pole is at the origin. It's like this. Pole is at the origin. So, not pole, the optical center is at the origin. Sorry, pole we say for mirror. Right. Whenever we make any ray diagram, the usual convention is that the rays will always travel from left hand side to right hand side. It's a lens, remember. So in a lens, it is not necessary that the rays are always coming from here to my specs. They can go from this side also. But optics, as I told you, everything is imaginary. The geometry has been done to satisfy the phenomenon. So the rays are taken to travel from left hand side to right hand side. This is how we will study. And the objects are always placed, on the left hand side of the lens. The object is placed always on the left hand side of the lens. And the object is kept erect. Like today, CBSE grade 10 guy was saying, sir, why is the object taken erect? I said, it's a custom. When you enter somebody's house, you enter with the right hand or right foot. You give things with the right hand. It's not that going with the left hand means you have malicious intention. That's a convention. Objects are always kept as erect. Huh?
What is erect?
I didn't get you. Come again.
What is erect?
Erect means straight.
Oh, straight.
Straight. Erect, inverted. Erect, inverted. Okay. So the object is always taken as erect and the image will be seen inverted. Okay. Now, inverted or erect, that depends upon it. Now, the rays always travel from left hand side to right hand side. Then this book part will become very clear to you. All distances are measured from the pole. Not pole, the optical center. All distances are measured from the optical center. What I mean by that is, if you measure a distance this side, then when you do numericals, though you don't have numericals, then such values are taken as negative. Right? Then if you go this side, such values are taken negative. If you go this side, such values are taken as positive. If you go this side, such values are taken as positive, just in accordance to the x dash o x and y dash o y. This value will be negative, this value will be positive, this value will be negative. Have you understood? And everything that we are going to measure from the optical center. Which one? Oh, that should be positive. This one. This will be positive. Clear? So the first thing that comes to us is, from here, if we try to understand, the object height is always denoted by HO, and HO by default will always be positive when we do numericals. So if somebody tells you an object of 3 centimeter, so we will take it as +3 क्योंकि object को हम हमेशा सीधा रखते हैं. Clear? Understood? The object distance in a ray diagram, object distance is denoted by U. How to remember? I'll tell you. Object distance is denoted by U, and U will always be negative. Why? Because the object is kept in front of the lens, and the distance will be measured from the optical center. So how they will use the language? The language they will use is, an object is kept, it's not there in your Cambridge, but if you go for any other board at this level, is there. An object is kept 30 centimeter in front of a lens. So you will take the value of U as -30. Because the lens object is on this side. I told you, na? All measurements are done from optical center. And in your mind, you should think the optical center to be something like the origin. ये ऐसे सोचने से तो हो गया ना. You think it as the origin. Clear? Our next thing comes is the focal length. What is focal length? Distance of the principal focus from the optical center. A lens has two focus, principal focus, secondary focus. But my rays are always taken to travel in this direction. So they will converge on the principal focus, which is this side. Do you agree? So my focus would be somewhere where? My focus would be, say somewhere here would be my focus. I'm writing this as F, right? I shouldn't write this F. I should write this as capital F. F is the length. So focal length, which is denoted by F, should always be positive. Why? Because I'll be measuring my focal length from the optical center. Have you got it? Okay. Then comes my image distance. Image distance. Image distance is denoted by the letter V. V. How to remember? If you want an aid to remember this, then the aid is very easy. Remember the word VIP. V stands for image distance, I stands for image. So you will never fumble between what is U and what is V. It's between U and V. One stands for object, one stands for image. So if you remember VIP, then I stands for image. So V stands for image distance. As simple as that. Did you get the trick? If you have a better trick to remember, you can remember. Don't write this in exam. This is only for you. Now question arises, sir, what should be the image distance? Depends. If the image is formed on this side, then we will say the image distance is negative. If the image is formed on this side, we will say the image distance is positive. Sir, how do you know which side the image will form? For this, we use something which is known as the thin lens formula or the lens maker's formula, or we call it simply the lens formula. The lens formula stands like this. 1 upon f is equal to, okay, 1 upon f is equal to, this is the part that is there in CBSE, ICC, you don't learn, but it's better you know it. 1 upon f is equal to, okay, remember like this. In India, we have what type of culture? VIP culture. So VIP means VIP always is given first precedence. So V comes first. 1 upon V minus 1 upon U. Similar to this formula, we also have a mirror formula. Mirror formula. The mirror formula is different. 1 upon F is equal to 1 upon V plus 1 upon U. Look, the beauty of this formula. In mirror, it doesn't matter whether you put 1 upon U first or 1 upon V first because it's an addition. But the protocol we will maintain is VIP. V comes first. So it's always 1 upon V, 1 upon V. Now, how to remember throughout your life that you don't juggle up between the plus and the minus? There is also a technique. In mirror, there is a word called I, and in addition also, there is a word called I. Just remember, mirror has got a word I, addition has also a word I. So the mirror formula always uses addition. How to remember here? Lens has got a word E, and the word negative also has a word E. I used to remember in my school days this way. You can remember this way or any other way. So this is these are not there, but if you understand these, then job becomes easier. The thin lens formula. Okay. And we handle another formula. For that, we need to understand it. So all we will be interested in such sort of problems is to understand facets about image. So once an image is formed, our interest will be to understand what is the position of the image? Position means what? Is the image formed in front of the lens or behind the lens? In either cases, by how much distance has this formed? So when we do numerical, I get a value, say v equal to -25. So I understand -25 is this side. I write that the image is formed in front of the lens. How do you say in front? Well, the object was kept on this side, so this is the front of the lens, in front of the lens. If my answer would have come v is equal to +30, the image is formed behind the lens. Have you understood? Okay, so we'll be interested to know the position. Then we would be interested to know what is the nature of the image. By nature, we will be talking on two things. Is it real or is it virtual? Is it inverted or is it erect? Now, what is a real image? A real image is an image which is formed by actual intersection of rays. And what is a virtual image? Well, a virtual image usually doesn't form, it is virtual. In Hindi we use the word abhasi. So, mera man ka bhram hai. So, in a virtual image, the rays will never meet. And when the rays don't meet, when the rays become divergent, so I pull them backwards. And I conceptualize that they must have met at some point. I need an image. And for an image, I need the rays to intersect. In reality, the rays are never intersecting. Why? There can be two cases. Either the rays become parallel or the rays become divergent. The rays are divergent. Divergence don't meet ahead, but divergence when pulled back can definitely meet. Such pulling back action is known as extrapolation, which you're doing from your own side. Not happening naturally. It's your conceptualization, so that gives you a virtual image. And a virtual image can never be taken on screen, we say that. Real images can be taken on screen.
So how do we know if the image is formed or if it's virtual?
That we'll see from ray diagram. You will yourself see. पहले ये नियम कानून समझ लेते हैं. पहले नियम कानून देख लेते हैं, फिर अपने आप समझ में आ जाएगा. ठीक है? And the third thing that we will be interested to know about, which is again of importance to us, is what is the magnification of the image. Right? यहाँ थोड़ा समझना पड़ेगा. आइए. Now we get to understand something called magnification. Whether you are dealing with mirrors or you are dealing with lens, magnification as a aspect will always be denoted by two items. The first one will be a sign. So obviously it can be either a plus or it can be a minus. The second one will always be a value. So this is a number. This value is usually a number, and the number can have three types of values: equal to 1, greater than 1, less than 1, either in decimal form or in fraction form. Proper fraction means less than 1, improper fraction means more than 1. And there will be something called plus and minus. Now let's use some common sense. I have bought a camera with a lens whose zoom is 80x. 80x means not x, it is actually the multiplication. 80 times it can magnify, or it can make it 80 times far away thing. You understand? So let's say I am standing for some event and you are making a standee out of me. Standee, you know, the standees which are there in IPL or cinemas or theaters that you get, they're called standees photo. So if the standee is exactly same as what I am, we say it's a life-size photograph. What do we say? Life-size photograph. In that case, what is the magnification? 1. It's a 1:1 photograph. The photograph that you see in your iCard is a diminished, or it's a smaller. So the magnification factor is less than 1. And say tomorrow if I'm contesting for elections in Telangana, then at Appa Junction you will see my big cutout. So in that case my magnification is now greater than 1. So have you understood? So greater than 1 means this will always be larger than object. Clear, bacha? I'm doing this in detail so that it helps you in your next grade. Same size, and this is smaller than object. क्लियर हुआ? तो फिर से समझिए, this is a pen. You can have the image which is smaller than pen, magnification is less than 1, same as the pen, magnification equal to 1, bigger than the pen. अब ये जो इमेज फॉर्म हुआ, मेरे हाथ को देखिए, ये इमेज ऐसा भी तो हो सकता है, inverted. Why do you think it will always be सीधा? So it can be ulta also. So that will be addressed by this plus and minus. If you are getting a plus value, means you are getting an erect image. If you're getting a negative value, means you're getting a inverted image. So let's do a small quiz. I say that the magnification of this lens is -3. -3. That means this lens, not this lens, this image is -3. So I say the image is 3 times as large as the object, but it is inverted. The magnification is +1. So we say that the image is of the same size of the object and is erect. The image is +0.2. We say that the image is erect, but it is smaller than the object. 0.2. Is this clear? Very good. Okay. And take down the formula for magnification for a lens. Magnification for a lens is given by the formula V upon U. V upon U. Magnification for a lens is also given by the formula H, image height over object height. Now see, you'll automatically answer. Look at this. Look at this. If the image is bigger, then this ratio will be more than 1, which satisfies. And if the image is erect, then the image will be formed in which manner? This manner. So the image height will always be positive. Positive over positive means I get a positive quantity. पल्ले बैठ रहा है? Hey, all of you, did you understand from this thing? If the image would have been big, but it is inverted, this will come with a negative sign, -5/3. -5/3 tells me that the image is larger than the object, however, the image is inverted. Have you understood? So we should also know, since पढ़ रहे हो, I can't stop myself. If you want to know the magnification for a mirror, there is a slight change here. For a mirror, it is always -V upon U, which is also equal to HI upon HO. HI-HO ratio doesn't change, but if you want to express the magnification in terms of -V upon U, in terms of V and U, then it becomes negative. For a lens, it is V upon U. In fact, this video will become a very good reckoner for a CBSE guy also. Handy. Clear? Shall we now look at the images? Go back to the previous slide. I said that there is one case where we will see magnified, erect, and virtual. That means there is only one case where in convex lens M will have a value plus and greater than 1. One and only case. And this case will be that of hand lens, the detective hand lens. What do you see with that? I see something which is bigger, I see something which is erect, and I see something which is virtual. एक ही case दिखेगा. That means in all other cases, something is guaranteed to me. I will be seeing things which are inverted. For in these cases, my M's value will be negative is for sure. It can be negative greater than 1, equal to 1, less than 1. Rest all cases, the magnification will be negative. Negative means उल्टा, उल्टा में बड़ा, उल्टा में एक साइज या उल्टा में छोटा. पर सीधा में छोटा होता है? No. सीधा same size होगा? No. Then don't use a lens, use a glass. What do you see through a window? +1. Only the lens can give you more than 1. ये केस. इसी से शुरू करेंगे. Right? This happens in mirror also. In mirror in concave. I said in mirror, what do we study? Concave. concave mirror, only once you will get an erect mirror, erect image and a enlarged image. You know what is that mirror? If you go to a dentist, the dentist always puts a mirror in your mouth and looks at your teeth. So what is he or she is interested? The Siddha teeth, the enlarged teeth. And there is one more, which you girls know like anything. The compact mirror. You want to have a bigger view of your lips? So in CBSE, we study it like this. I say, remember one thing, lipstick, 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 don't forget. The vanity mirror is always a concave mirror. The mirror which is on your car's sunshade. जब तक ट्रैफिक था मैंने एक और मेबलिन का शेड लगा लिया. There we are not interested to see the whole face, only a short part and enlarged. And even if you go to the optician or the spec shop, there will be some desk mirrors. Have you seen? Where people put the specs and they see. उसमें आप अपने आप को life size नहीं देखते हो. Only the gal portion. How am I looking? The face view. So that is also known as a concave mirror. How to check a concave mirror? The best is take a spoon from your dinner set today when you go home. Don't take the spoon that you've been eating every day that has become dull. The very spoon which you keep for guests coming at home. The spoon is a very nice example. The spoon is convex on one side and the side through which you eat, that is a concave side. Concave. Concave means man is sitting under a cave. Concave. Take that spoon and bring it near your lips. You will see yourself Siddha. Enlarge. The dentist lipstick case. If you move it far away, you see yourself Ulta. Always. So let's go. Number one. So the first one would be the hand lens case. And now we are going, what is in your book, they have done in 3 or 4 short figures. So this is my principal axis. And obviously I should have my axis of my lens. So this is the axis of my lens. Have you understood, children? Right? Your book is not drawing the lens, but I am habituated to draw the lens. So let me draw my lens also. This is my convex lens. Right. And this is my optical center. Oh, I am supposed to have a focus on this side, which is my primary focus. And I'm supposed to have a focus on this side also, which is my secondary focus. So what does this focus mean? If the rays of light are coming from this side, they would converge here. But since we are doing ray optics, this is our focus, primary focus. Lens ko do focus hote hain. You can't snatch this focus away, but you snatch it away when you're doing the ray diagram. Okay, this is F. And then we have another distance which is known as the 2F. Twice the focus. So you can also have a 2F dash out here. Now you must have seen that whenever any person is using a lens as a magnifying glass, he will hold the lens very close to the object. So in this case, if you want to get what? Erect, virtual, enlarged image, ensure your object is between optical center and the focus. इसके out आप करोगे आपका object क्या हो जाएगा? टेरा हो जाएगा, image टेरा हो जाएगा. So we say object is placed between focus, that is F, and optical center. What is the optical center? O. It's placed between F and O. So let's understand and go by your rule book. What does the rule book say? The rule book is very simple. Ray of light which is parallel to the principal axis, all we need to find out is how the head of the object behaves. So I'm interested with the ray which is going through the head. Understood? It will always pass through the focus. Rule number 1. Do you remember?
Yeah.
Right? And the second rule, it will always pass through the focus. Okay. Now, since I'm drawing it freehand, so maybe the geometry may not come exactly the way you want, but if you draw it properly, it will come. And the next ray is taken in such a manner that a ray of light which passes through the optical center, a ray of light which passes through the optical center goes undeflected. Do you remember, children? usually these rays, see my diagram is not correct. These rays should come a little bit divergent. Okay, hang on. So I'll just, pardon me, I'll just slight change the position of the object because I'm not, can change it. Imagine that, children, pardon me for this. This is not the object. This is the
Where it meets.
the eraser is not working. Where it meets, that is the object. This is the object. Or let me do it white was unnecessarily. So I'll not draw the object this time. Okay. What's happening? Oh, take selection. Let me try this. It's much easy. You optical. Sorry. Oh, okay, fine. So let me take away this part. Let me draw this part again. No worries. I'll draw it again. Okay. I'm deliberately not drawing the object as of now because else it becomes difficult to maintain the symmetry. Through the focus, and another ray which passes through the optical center goes. Now I'll bring my object, and my object is here. Tell me, children, have you understood? So let me name my object. B is the foot of the object. A is the head of the object. Right? Now, if I look at these two rays are divergent. Will they ever meet? They will never meet. But I need an image. So only option that is left with me is what? Extrapolation. So what I do an extrapolation of this particular ray. I do an extrapolation of this particular ray. And if I take it here, it's gone somewhere here. And this ray was originally coming. Imagine that they're meeting here now. Imagine they're meeting here. So what will I get? I will get my image. Has my image formed by actual intersection of rays? No, my image has not formed by actual intersection of rays. And so this image we will be showing, the nomenclature is to show it with a dotted line. Now what is important for you to note here is, sir, why did you draw the image upwards? Because the head has gone up. Look, the rays are from the head. Are you understanding? The rays are from the head. They have gone upwards. Foot यहीं पे है. अगर यहाँ intersect करेगा ना तो उल्टा बनेगा. So this is my image, and this is B dash, and this is A dash. Now let us put our comments about the image. What will be our comments? Position. Position would be in front of mirror. Sorry, not mirror, lens. In front of lens. What about the nature? Tell me. Virtual. Virtual and erect. And what about the magnification? Magnification. We will say that the magnification is larger than object. Larger than object. No, here we don't say positive and all because this is the theory part. It is obviously understood positive because it is erect, right? Because it is erect. this is the only one and only case where a convex lens will show this. And what is this case? This case is nothing but this case. एक ही बार दिखाएगा और कभी नहीं दिखाएगा. ठीक है? Now, did you remember that when we had drawn, when we have already covered one image, this is case number 1. We already covered one more case. We say object is at infinity. If you remember, we have covered it. How did we define the principal focus? We took a parallel beam of rays which were traveling from infinity, and where did they converge upon? They converged upon at the focus. So when the object is at infinity, you remember burning paper using a hand lens and the sun is at infinity, all the rays converge upon at the focus, and that small dot which you are seeing is nothing but the image of the sun. It's the image of the sun. Remember that diagram, or should I draw it again? If you remember. And then we said that there can be a focal plane also. If the rays are not parallel to the principal axis but are somewhat like this, then the image will be formed at the focal plane. Let's see that so that it gets clear with you. ये drawing को आप दो तरह से देख सकते हैं. Now I'm making some freehand drawing, okay? Now this is my lens, and I am having my rays which are coming parallel to the principal axis. Let's say first the rays are parallel to principal axis. As per my rule, where should they converge upon? At the focus, not focal length. And that is how we define the principal focus, at the focus. This is the mischief you used to do in childhood. When you kept paper here and hand lens, the sun's image was formed here, all the rays, and the paper automatically started burning. Huge concentration of rays. Now, say suppose I want to see the image. So object is at infinity. Here our observations will be like this: position, nature, and magnification, right? The position will be always at focus, or you will say at the focal plane. You remember what was the focal plane? The focal plane is a plane which is kept perpendicular. Take a A4 size paper like this and keep it like this. This is the focal plane. If you are coming parallel, you will form at focus. If you come parallel but not parallel to principal axis, your image will be formed on the focal plane. Okay. And what is the nature? The nature will be real because actual intersection. And here we will get inverted. Sir, in a sun, how are you saying whether it is inverted or not? So we'll prove the inversion also now. And magnification will be highly diminished. Highly diminished. Diminished means extremely small, like a dot. So let's see this diagram to prove that it will be inverted. So this is my lens. Clear, bacha? And now I take my rays. I take my rays in such a manner that the rays are coming parallel, but these rays are not parallel to the principal axis. These rays will still converge upon, and they will converge upon at a point on the focal plane. What do I understand by focal plane? By focal plane, I understand that this is the axis of the focal plane, and the original focus is somewhere here. So if you want more better explanation, this point is this point.
Okay, yeah.
But if the rays are coming this way, you'll get it. Now, if I try to, and the object is far, far away, so we don't draw the object. Now I will not draw a dotted image, but I will draw a complete line image because it's actual intersection of rays, and the head, the image was far away. Sorry, the object was far away, so the object was a सीधा, और उसका image उल्टा बना है. क्या ये आपको समझ में आया? Right?
Should I get it or it's inverted?
I didn't get you. Tell me.
Get outside inverted.
Inverted because the object will always be kept erect, na?
Yes.
This is the object. The rays are coming from the head of the object.
Yes.
So they are going and meeting below this x-axis. That's why it's inverted. अच्छा, तो इसका उल्टा देखते हैं. If the object was at focus, where do you expect the image to form at? When the object is at infinity, image is at focus. ये हो गया the mama and the bua story. If the object was at focus, if the object was at infinity, image is at focus. So if the object is at focus, the image will be at, no sir, you show it, हम ऐसे विश्वास नहीं कर सकते. So let's say, let me change it. Sorry. Okay. So 1, 2 gone, third. Sorry. Yeah, I could have finished it in shortcut. My heart doesn't agree that. Object is at focus. Then your clarity will come. Object is at focus. Again, I am drawing freehand diagrams, okay? Object is at focus. So this is my F, F, F dash, 2F dash, 2F. Here, children?
Yeah.
So, and this is my O, optical center. The object is where? The object is at focus. This is my focus. So let's go by our rule book. A ray of light parallel to the principal axis passes through the focus after a refraction. Any doubt? Okay. And then we will say that another ray of light which is passing through the optical center, what was the rule? Goes undeflected. Goes undeflected. Right. यहाँ थोड़ा सा आपको आर्टिस्ट इंप्रेशन होना पड़ेगा. आर्टिस्ट इंप्रेशन मतलब समझने की ताकत रखनी होगी. Okay, it is going undeflected. Observe the nature of the rays, refracted rays. Parallel. Do parallel rays meet? इसको extrapolate करके भी कोई फायदा नहीं. Parallel है ना? When the parallel rays don't meet, the concept that we apply in optics is that कहीं तो meet करता है. कहाँ मुझे नहीं पता. Some far off place it means. Where is the far off place? Now I'm going this side. F, 2F, 8 hour, outside Pebble City, Hyderabad, more far, some infinity it meets. Sir, who gives you the right to think that the parallel lines meet? Okay, think that you are standing in between two railway tracks, not to commit a suicide. Don't you feel that the railway tracks meet somewhere ahead? Any two parallel things will always give you a feel, it meets. Go till that portion where it meets, it's like a mirage jaisa hai. Once you go there, you see the railway tracks are meeting far ahead more. You still keep running, but it gives you an apparent thing. So here we say, but as we go off and go off and go off far away, and if it is actually meeting as per our concept, what is happening to the height? What is happening to the height of the image? यहाँ पे image छोटा था. Now the height is increasing. Don't you think a huge image is going to get formed? So let's write, when the object is at focus, what is these are everything that we are writing for the image, okay? Position will be, the image will be formed at infinity. हमें नहीं पता कहाँ है, बहुत दूर है. These become almost what is known as parallel rays. Now पिछला वाला चीज याद करो. Far off rays are taken parallel, then rays which become parallel must also be meeting far off. As simple as that. Distant object rays are taken parallel, so parallel rays also must be meeting at some distance, far away, at infinity. Okay, what is the nature? The nature will be real, no doubt about this, because they are going to intersect where we don't know, and it will be inverted. it will be inverted. So if you use a convex lens and you try to get, not this, I'm trying to say this example. If you take a convex lens and you try to get the image of Uranus, you get an inverted Uranus. But Uranus is goal, na? Inverted se kya matlab hame? Therefore, if you use field telescopes and try to astronomical telescopes and you try to see people on the field, you will see everybody ulta. Because a telescope has nothing to do with ulta and seedha. Does a telescope magnify? Never answer that like an idiot. A telescope never magnifies. What you see, Jupiter is not the size of Jupiter. English. Tele को scope में लाता है. It brings the tele objects in your scope. Tele means far away. And it brings you to your scope. A telescope does not magnify. A microscope magnifies. A bacteria is this small, which you see this big. Or a paramecium, which you say like a shoe sole, is actually this much. Telescope never magnifies. Does a binocular magnify? No. A binocular brings tele to your scope. Tele objects in your scope of vision. Many children, they think telescope magnifies. Telescope doesn't magnify. And if you want to understand it with a, is the size of Jupiter this much? Then, okay, parallel rays ho gaya. And what about the magnification? Highly enlarged. देखो, seriously पढ़ाने से time हो जाता है. Highly enlarged. 4. Between F and 2F. Between F and 2F. Here also I'll do a little bit of jugglery and a little bit fast. So your book has got all the diagrams, don't worry. So this is your F, rather F dash. This is 2F. And this is 2F. O, 2F dash. Now you're keeping where? You're keeping between 2F and F. Always remember 2F and F में रखने से 2F के बाहर image form होगा. The image will be formed, or bahar means it will become an enlarged image. I told you, everything other than the doctor's hand lens, we will be seeing inverted. The last one was inverted. This one is inverted. And now the one we are going to see will also be inverted. Object is here. Right. So let's do some jugglery type of thing again. Ray of light which is parallel to the principal axis will pass through the... will pass through the focus, right?
Yeah.
And we use our favorite law. What is our favorite law? A ray that passes through the optical center. Again, some sort of jugglery will be required. From the optical center, the diagram is again distorted. It should have come beyond 2F, okay? How do I make it? So 1 minute. So let me first make the diagram and then let me put the objects. There's no other option I have. Okay. We'll finish it in one go, children. No point in keeping it. Focus and a ray which comes now better. Okay, so this is where my image will be formed and this is where my object is. So now I just mention them and let's say this is F dash, this is F, this is 2F, and this is 2F. Right. So what do we say about position? Our position is beyond 2F. Nature erect and real, magnification larger than object. The next one is just the opposite of it. Object is kept beyond 2f. Where will the image be formed? Between f and 2f. Image will be smaller. Lens में just rotate this. देख लें, दो ही है, फटाफट देख लेते हैं, आ जाओ. Just two more. So our next one is,
Sir,
yes sir.
sir, can you understand the difference between the object being error and inverted?
Object being,
So being inverted and error. How do you know inverted?
oh sorry, I wrote it wrong. This is not erect. Actually, I also got tired out.
Okay, this is downward.
Yeah, inverted. Sorry, it's inverted. Everything will be inverted. Real is only one case. Sorry, erect is only one case which we have already done. Erect is only one case, the doctor's hand lens. Rest all will be, sorry, this is inverted. Thank you for correcting me. And then let's take the last two. फटाफट कर लेते हैं. The last two. This is one, and this is one. I will not name F and O all the because my other diagrams are not scaled. Object is beyond 2F. The object is beyond 2F. So let's make our diagram. A ray of light which is parallel to principal axis will pass through the focus. Okay, and there has to be another ray, and that other ray would be the ray which is it will become much more smaller. In exactly, it has to be smaller. Okay, so that is where you get your object. This image will be smaller, huh, bacha? This has to be smaller. So let me mark it now. So this is my F. So this is F dash. This is F dash. This is 2F. And here will be 2F. So when the object is beyond 2F, let's see the image. Position between F and 2F. Position is between F and 2F. Nature, inverted and real. Magnification, smaller than object. I hope I wrote the last one correct. Larger, yeah, larger than object. Fine. And the last one. The last one is object at 2F. Now use your common sense. If you are keeping the object on this side of 2F, no, you are getting an image which is beyond and you're getting larger. If you're getting on this side of 2F, then you're getting an image which is smaller. So अगर आप 2F में रखेंगे तो कैसा आएगा? Exactly the same. Yes, that's the trick. So at 2F, we're going to have like this. A ray of light which is parallel passes through the focus, and another ray of light through the focus. Say process in this manner. So here we will have this is my image, and this is my image, and this is my object, and they will be of same size. Pardon the drawing. So this is optical center, focus, 2F, 2F dash, f dash. So object at 2f, the image that I will get, position will be at 2f. Then nature will be inverted, real, and magnification same size. Can you tell me in value what it will be? -1. Magnification is always with a sign, -1. What will be the magnification value here? M will be equal to, it's a bigger one, so the smaller, negative less than 1, right? What will be the magnification in this case? It will be a negative greater than 1, means this value will be greater than 1. What will be the magnification in this case? Negative substantially greater than 1. And what will be the magnification in this case? Positive greater than 1. Don't use this greater than 1 and positive. This positive is a different positive, huh? Bas. And out here, what did we get? This will be, magnification would be negative substantially less than 1. Is it clear now? Then it gives me also satisfaction. The next topic is dispersion of light. That is how light spreads into 7 colors in a prism. Is just one paragraph. So let's go. ऐसे पढ़ेंगे तो समझ में आएगा आपको. ये just उन्होंने one page में खत्म कर दिया. And we need to discuss. On our next class, we will be discussing something very interesting all about eyes, which is you should know. Eye diseases. Fine. Yeah, in physics. You should know. Right then, closing the recording.